Hello, I welcome you all to this another interesting screencast, and the problem reads 150 pounds crate is supported by cables AB, AC, and AD. Determine the tension in these wires. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Okay, so you could solve this particular problem by either using the vector or using the scalar or a combination of both. Okay, I could find, so for the vector, I'll need to find the unit vector along the direction AB and AC, later on convert, and also AD. We know already AD is along the x-axis, so it's just an I unit vector. But along the AC and AB, takes a little bit of time. Do the unit vectors, calculate, multiply the unit vectors by the forces AB, and the unit vector in AC also multiplied by AC, and later on sum up those forces vector using vector principles, and then separate them. Equate the x's alone, the y's alone, and the z's alone equal to 0, and then have three equations, and then solve the unknowns because we have three unknowns. Or if you want to, you can find the slope of AB. You find the slope and then map it on the xy plane, map it like so, and then come and use this to map on this direction and map the other direction like so. So you can use also this technique, but it messes up some, especially when you have a lot of cables. It messes up the work. Sometimes the lines are too many. Or if you want to, you can find the angle. Find the angle. So you'll have here so you have component here. You find the angle, let's call it alpha, and then let's call it beta, and then you have for this other component there, let's call it gamma. So you can find these angles and so on. I think for the angle part, I feel it's a little bit better because you know that cos alpha is just equal to the component of the unit vector, right? So what we need to do is just find the magnitude of each of these lines, and once we have the magnitude, then we can use that magnitude plus the length on each side to find that particular angle, right? So we know that this force here, AB cos, let's call this angle here, let's call it just beta for now. Okay, so we know that beta, cos beta is equal to the length, the side, because this is where B is. So this length here at B in the y direction, which is a 3, divided by the magnitude of the line AB, which is 3 squared plus 6 squared plus 2 squared. Okay, so this is how we do it. So instead of using this can be also written as just AB 3 over 3 squared plus 6 squared plus 2 squared. Okay, so I think we're going to use this particular method, right? So let's do that. So let's find the length of AB. AB is just going to be equal to square root of 3 squared plus 2 squared. We are using Pythagoras plus 6 squared, and therefore AB is just equal to 3 squared plus 2 squared plus 6 squared, 49. Therefore this is 7. AC is just equal to 2 squared 2 squared plus 3 squared plus 6 squared. AC therefore is just going to be equal to it's the same, right? It is the same. This is also equal to 7. Great. So therefore let's start now working out the component. You need to know, because look at this, you need to know how to map this. We know that you need to know in which direction you are going to be mapping your forces, okay? So that I mean the sign and so on. You need to know that so that you don't mess up the work or you don't confuse the work, okay? So you know that for these components, you're going to have a component in this direction like this. You have a component in this direction like this, okay? And this value is just equal to AB, mind you. We have sectioned these, and once we've sectioned them, you have a tension force, okay? And so is that side. You have and this is equal to AB, and this is equal to AC, okay? So therefore this component becomes equal to AB, and we said this angle here is equal to just the length 3 divided by the hypotenuse, the length of AB 7, okay? So it's just equal to 3 over 7 AB, okay? And the same goes for the other ones. This component will be in this direction. Like I said, you have to know the direction, okay? This will be in this direction. Let's say this one is AB. The length in this direction is 6 divided by 7, which is just equal to 6 over 7 AB. And then we have the vertical component. And this one is equal to AB times the direction in the vertical component, which is just 2 divided by 7. So this is just 2 over 7 AB. So we are done with this one. So this can be a little bit fast. So then we go to the other one, which is AC. So S will have a component in this direction also, okay? And this one is equal to AC times the component in the vertical direction, which is a 3 divided by 7. AC is 7. So this is just 3 over 7 AC. We'll have a component also here in this direction, okay? And this one is equal to AC by the direction in this, the length in this direction is 6 divided by 7, and this is just 6 over 7 AC. And then finally, we do have a component in this direction, okay? And this is just equal to AC direction, the length in this direction is just a 2. So we have AC by 2 divided by 7, which is just equal to 2 over 7 AC. Okay, so we are done. We are done just like this. This is a little bit faster. Then we can apply the equations of equilibrium. While we have this other one here, so we do the sectioning. We are going to have force in that direction like so. So there we go. and this force here is just equal to AD. Okay, right. Let's start working on this problem. So we have summation of forces in the x equal to 0. So what do we have in the x? We have AD. What else? Minus 6 over 7 AB minus 6 over 7 AC equal to 0. Then we have summation of forces in the y equal to 0. In the y, what do we have? We have 3 over 7 AB. Then we have minus 2 over 7 AC equal to 0. Then we have summation of forces in the z equal to 0. We do have one force that I didn't indicate. We do have a force. The weight of this is equal to 150. Okay. What do we have in the z? So we have 3 over 7 AC plus, let me start with AB. Not that is important, it's just my preference. I just want it to align with summation of forces in the y. Okay. So 2 over 7 AB plus 3 over 7 AC minus 150 equal to 0. So we have the first equation, we have the second equation, we have the third equation. So using the second equation, we can say AC is equal to 7 and 7 can go. So AC is equal to 3 AB divided by 2. Then we can feed this into there. Okay, and once we do so, then we'll find that our AB is just going to be equal to, you can grab your calculator, feed it, start working out. So 2 over 7 plus 3 over 7 3 over 7 times 1.5. Okay, 3 over 2 is 1.5. Then we have the 150 divided by that. So we have a 161.54. Okay, so 3 over 7 by 3 over 2, okay, plus 2 over 7, and then 150 divided by that, 161.54. So we can feed this value here. No, we can feed it just here. Okay, then we have AC is just equal to times 3 over 2. So this just becomes 242.331. Okay, 161.54 by 3 over 2. Okay, 242.331. All right, and then let's feed AB there. AB is just equal to 161.54 and AC is equal to 242.31. AD therefore is equal to 6, okay, you can factor out that. So it's 161.54 and 242.31 and times 6/7. So this gives us a 346.16 pounds. So we have 6/7 times 161.54 and 6/7 times 242.31. So 346.16. All right. I think this is about it. Let me just outline the solutions. We have found the values of AD. We found AD, AC, and AB using this particular method. And if this video was helpful, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.